Vertical slip forming is the fastest and most efficient method for casting reinforced concrete walls in many types of structures. It is a construction technique that utilizes a mechanized moving platform system enabling semi-continuous placement of concrete. The principle of this technique consists of constructing a wall-shaped form of reduced height, usually 3.5 to 4 feet high, on the foundation of the structure to be built. The form is constructed rigidly and precisely, outlining in plan all of the walls in the structure that are to be cast. The form is not fixed to the foundation, nor are form ties used to secure the form panels, but instead they are held together by means of steel frames called yoke frames and suspended from a series of lifting devices which are supported on steel rods bearing on the foundation and which become embedded in the concrete walls. Once the form has been filled with fresh concrete and hardening has started, the form is gradually raised by the lifting devices from which it is suspended and progresses upwards along the steel rods, which are continuously extended as upward progress is made. Pouring of the concrete, placement of reinforcement, and installation of all blockouts, inserts, and embedments is performed gradually from work platforms permanently attached to the slip forms and which rise together with the forms. Finishing of the concrete surfaces, quality control inspection, repairs, and removal of blockouts is done as well immediately as the concrete emerges from below the form from a series of scaffolds and platforms suspended some 10 to 13 feet below the main working decks. All of these operations, as well as materials handling, is planned and organized to provide a predetermined rate of production coinciding with the rate which the slip form rises. The slip form may be operated continuously by working 2 or 3 shifts to produce about 24 feet of wall height per day, or it may be started and stopped each day, as is common in building construction work, to produce one floor height of between 11 and 13 feet during normal working hours and without overtime. Aside from being the fastest method presently available for casting concrete walls, slip forming results in a very efficient use of craft manpower, since all of the work must be performed on the basis of the concrete setting time and the movement of the form, both of which are determined in advance. Forming costs also are lower, particularly on tall structures, since the form, once constructed, remains intact until the structure is completed. All of the important safety and accommodation installations are installed prior to the start, and because there is no repeated dismantling and reassembly of the form as in conventional pour forming systems, the hazards associated with these operations are eliminated. Finally, slip forming achieves improved concrete quality. Not only is it possible to pour a monolithic concrete structure without construction joints, but since the concrete is poured and vibrated in shallow layers, low water-cement ratio mixers can be used and consolidation is improved. The slip form technique is applicable to many types of structures. Most frequently, it has been associated with the construction of concrete silos and similar storage structures in the agricultural, coal, and cement industries. The technique, however, is equally suitable to many types of building structures, from the slip forming of shear walls in apartments and hotels to central concrete elevator and stair cores in high-rise office buildings. In addition, a variety of other types of structures, from observation towers, nuclear containment buildings, underground shafts, and offshore oil platforms, have been constructed by the cost-effective slipform technique. Rising to a height of 1,815 feet above Toronto's skyline, the CN Tower, shown in this photo, is the world's tallest freestanding structure and is the greatest monolithic achievement of Canada's slipform technology. Canada's slipform system. Let us help you to become an expert slipform contractor.